So, welcome everyone to the meeting. Today we're going to be working on the CCC preparation. So, the CCC is the Canadian Computing Competition. It's a competition held by Waterloo for computer science, and yeah, we're going to be preparing for the senior contest, which is aimed for grade 11s and 12s. So, let's get started. I have the page. I'm just going to share my screen. Okay, share, and you should see it over here. Alright, here's the first problem on the senior contest. So it's called triangulane, and the description, so they give you like a description over here of what the problem is, and then they give you some inputs you need to put in. So like, they'll give you like, for example, pause. Yeah, I can zoom in. There you go. So they might have like some different inputs, right? Recently they started giving you like this mark breakdown, so like how their inputs will differ for the different marks. So you can get like, what's it, 15 marks here, right? So if you want to get like the maximum number of marks for each question in order to get a distinction. So basically our goal is try and get into the top 25%. So we're gonna try and teach you guys how to do S1 and do a little bit of S2. So there's 5 problems. If you can get like 2 problems and like half of the third one, you'll get into the distinction, I think. So that's what our goal is. So let's take a look at this problem. So Boshi the builder is just finished constructing her latest project, a laneway consisting of two rows, right, of white equilateral triangle tiles. However, at the last moment, disaster struck. She accidentally spilled black paint on some of the tiles. Now, some of the tiles are wet and the other tiles are dry. Boshi must place warning tape around the perimeters of all the wet areas, and can you help her determine how many meters of tape she needs? So the first triangle tile will point upwards, and each pair of adjacent tiles, that is, tiles that share a common side, will point in opposite directions. Each tile has a side length of 1 meter. Okay, so let's kind of visualize how this is going to look like. I'm just going to open up a paint here, put it to the side here. So for example, we could have tiles like this, right? This might be a valid input to our problem. And as you can see here, the first line of input will consist of one positive integer c, representing the number of columns. So for example, this we column 1, 2, 3, and so on, right? So the next 2 lines will each consist of c integers separated by spaces. Each integer represents the color of a tile along the laneway, one indicating that the tile is black and 0 indicating that the tile is white, dry. So for example, they're going to be giving us like 5, so this would be 5 of these tiles. Right, so 1, 2, 3, 4, 5, right? And then they're saying that this is how it's going to be looking like. So 1 means that it's colored in, so this is going to be colored in. 0 means it's dry. 1 colored in. 0 means dry again, and then 1 colored in. Okay, so it'll look like this. And you can even see here that they give you an example. So the tiles are painted as follows, creating 3 wet areas, and Boshi will need 9 meters of warning tape shown in yellow. So you guys understand that? The question's going like? You can look at a different example. Yeah, okay. So there's another case where in this example here, we have, as you can see, we have like 7 tiles, right? But 2 of these tiles on top of each other, they like all get combined into one, right? These 3 right here, they all get combined into one giant area, and we have to determine like how many of these side lengths that we need. So let's say like we're just looking at this. Like if you were doing this like as an actual human, what you would do, you would draw out the entire thing. You would fill in all the areas that are wet. So in this example, use 1, 2, 3, and then you would count how many side lengths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is your output for sample 1. Okay. Let's try for this second sample input, right? So we have 7. So 1, 2, 3, 4, 5, 6, 7. And then you need to color in these spots here. So the third one, so 1, 2, 3, I would color in this one, color in this one, color the one below it. Then I go 1 over, right, to here, and then 1 over to down here. And now I need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 meters for our output. And that's how you would do it, like if you were actually like as a human just drawing this out. But you're not going to be able to draw out 200,000 tiles long, right? That's way too much. So we're going to make a program to be able to solve this for us. So let's start off with just like this like simple one. We'll ignore this part here with the like black part here where there's like a line missing. You can see where it's like kind of combined it. We'll just like pretend that this is the only thing that exists for now. So I'm gonna do the first thing that I would always do whenever I make a problem. So I just make a new Python file. We're gonna be writing these solutions in Python just because it's what we've been using before, and it'll be pretty simple to explain it. So yeah, let's start off with the input specification. The first line of input will consist of one positive integer c. So we know integer is c, so c is equal to int input. Okay, very, very simple. Right? Next thing they want, the next two lines will consist of c integers separated by spaces. So each integer represents the color of a tile along the laneway, so yada yada yada. So let's go get our values into a list, right? Well, we need to like actually collect these values, right? So we'll say that the top row is equal to tuple map int input dot split. So I just wrote like a whole massive line here. I'm gonna explain what this does. So if we look at it step by step, it's gonna take the input and it's gonna split the input. So if your input was, for example, 1 0 1 0 1, what this is gonna do is it's gonna convert it into a list of 1, 0, 1, 0, 1, like that, right? So this is input.split, and then we're taking this and want to map integer to this list. So what it's going to do is essentially int 1, int 0, int, and so on and so forth, right? It's going to do that, and then our output is going to be a map object that will have basically 1 0 1 0 1, and we just need to convert it to a tuple. So a tuple, will put it like this, and that's how we're able to get all of our space separated values in Python with just using this one line. So that's pretty neat. So I recommend just like kind of memorizing this. It's not too bad after you use it multiple times. So just like when you're practicing for these problems, I can actually post the document link into the chat so you guys can take a look. I'll post that in the chat. If you just go on like the past contests for the CEMC, I can also post that link as well. So the second link that I posted there, those are the past contests for Waterloo, and you just scroll down to the bottom of the page and you can just look at all those different ones there. But anyways, we need to do this twice. So we'll just take all of this, Control D to copy it, to duplicate it, and we'll just make this the bottom row. So let's go test that we can get all the input. So if we run this, we'll get a little console at the bottom. Let's go copy in our sample input, which is this. Copy, paste. Okay, we got all the inputs. Let's just print it to make sure. I like to do this just to make sure I'm getting all the inputs correctly, so I'm not like missing anything or there's an error. So as you can see, this will get all of our inputs. Now, we need to figure out a way to determine how many sides there are. So you might have noticed a pattern, but each of these ones corresponds to one triangle, right? And we want the perimeter of the triangle, so like the outside edges. And each triangle has 3 edges. So 1, 2, 3, right, for one triangle. So we can basically just multiply for each one in here, we just multiply it by 3. So if we say our output is equal to 0, and then for value in, what can we just say for triangle in top row, right? If that triangle is equal to 1, right, it's a wet triangle, then we'll just do output plus equals 3. And we'll do the exact same thing for this bottom row. So this was kind of, what I'm doing right now is just going through like my thought process as I was actually solving it last year in the contest. This is the 2023 one. So if we just run this and paste in our output, we get 9. Okay, that works. Perfect. Right? We just got the sample output 1 right here. So that's really, really good. Let's try the second one. Maybe we can hope against hope that maybe this will work. Oops. Maybe not. And as you can see, it just gave us 15. The answer is 11. So we need to find a different way, and we need to figure out what is wrong, right? What we're doing right now is we're going for every triangle and we're counting this side here, right? Do you guys see this side? That's like between 2 triangles. We need to find a way to determine what side we need to remove, right? Like if we were to count, so like the idea here is that if we count how many triangles there are, like how many sides there are here, like even like, okay, let me re-explain that. If we were to assume that every triangle was independent like this, right, in this triangle, the idea is, like the kind of like key idea is, if we count for each individual triangle, there's 3 sides, and then we remove this side here by detecting which triangles are connected to another triangle, we can effectively determine, so like we would have like total sides for like the individual minus the ones that are connected, and that'll give us answer. Okay, so we can do that by simply going into our code. We already have the total number of sides if they were all independent. Now we just need to go loop through each row and just figure out how many sides is it connected to. So what I'm going to do is for I in range C, and we're going to do C minus 1 because we want to loop through every single value. So if we have like a list for every single value, right? If this value of C is 1, 2, 3, 4, 5, C equals 5 in this case, right? So C minus 1 will be 4. So we want to look at this one, and we're going to check the one after it. Then we're going to look at this one, check the one after it, then look at this one, check the one after it, look at this one, check at the one after it. And in this way, we will be able to like compare this. If this is a 1, right, then that means these are connected. If this one is also 1 and this one is a 1, then these are connected. So this way we can look to see which ones are connected, and we don't have to worry about this going back, right? We only need to look ahead because we've already looked ahead from the previous one. So that's why we're going for C minus 1. So if the top row, and we look at the current value, is equal to 1, and the top row I plus 1 is equal to 1. Now we can't do top row equals top row plus 1, right? We can't do that because if they're both 0, then that won't work, right? So just be careful of that. So if this current one and the next one are both wet tiles, then what we can do is output minus equals 2. Now why do we want to subtract 2, right? If there's only one side here. Well, both of these triangles have counted this side, So what we need to do is, because we don't need any of these sides, so we need to subtract 2 because both triangles counted it, right? And we do the exact same thing for the bottom row, so we can literally just duplicate that and just change this to bot row, bot row, bot row, right? And then lastly, we can't forget about when the triangles, like there's one on the bottom, right? When they touch like that, so there's still 2 sides we need to subtract. So we know we have to do output minus equal to 2. So if top row I is equal to 0, or is equal to 1, and bot row I is equal to 1. So if that is true, if they're the top and the bottom is equal to 1, then we output minus equal to 2. And then we need to do one last one. Oh, I forgot about this one. So this is only true when the sides touch like this, right? But if we have, for example, a case where this one is filled in and this one is filled in, then there's no sides that touch, so we still need to do all 6 sides here. So this is only if I modulus 2 is equal to 0, right? So this is only if it's an even number. So if only is this one, so this is 0, 1, 2, this is an even number. So only if it's an even number index, then you need to do that. Okay, lastly, since this one only goes up to the second last value, right, this value here, and it stops, we need to check the last value. So if c modulus 2 is equal to 0, and so this would be c minus 1 because that's the index we need, and top row, to get the last value of the list in Python, you just do minus 1 is equal to 1, and bot row minus 1 is equal to 1. Then we want to output minus equals 2. Now if we run this, and we paste in that 7 thing, you get 11, which is the answer to our output. So if you put this in, you'll get full marks for all of these cases, even with this one here that's like 200,000. So that's really cool. So yeah, that is S1. So hopefully you guys understand that. Did that make sense for you guys? Is that too complicated? Need any further explanations or no? For S1. It's good? Okay, awesome.